for the product, quotient rule, and implicit differentiation. The first is the product rule. Y equals x squared plus 1 and x plus 3. Instead of doing a bunch of annoying FOIL multiplication first, we can just split it into two parts. So the first part is 2x and x to the power of 3, and then we differentiate the second part, which gives us x to the power of 3 equals 3x. So we can do x squared plus 1 and then 3x to the power of 2. Then we can add them both together, which gives us 2x, x to the power of 3 plus x to the power of 2 plus 1, and then 3x to the power of 2. The next, we have the quotient rule for fractions. In this case, it is y equals x to the power of 2 plus 1 over x plus 3. Here, the derivative on the top is 2x because if you can remember from the previous videos, you use the power rule, which gives us 2x because 1 is a constant. And on the bottom, 3 is a constant, and the derivative of this is just 1. So then we can plug it into the formula to get the answer here. But do not forget to square the denominator, because this is a very common mistake. The last one on the slide is implicit differentiation. Here, it's x squared plus y squared equals 25. The first step here is to differentiate the two sides. The derivative of x squared is 2x, but for y squared, it's 2y dy over dx because of the chain rule. Derivative of 16, or the derivative of 25 is just 0 because it's a constant. So now we have 2x plus 2y dy over dx equals 0. Next, we can move the 2x over to the other side, which gives us negative 2x, and to finish the equation, we divide by 2y, which gives us dy over dx is equal to negative x over y. Moving on to the next slide, we can have the problem y equals x squared plus 1, x plus 3. And if you can remember clearly from earlier, this is a pretty straightforward problem. We start by differentiating the first part, which is 2x, and then x plus 3, and the second part, which would be just x squared plus 1, 1. So the final answer would be 2x, and then x plus 3 plus x to the power of 2 plus 1. And of course you can simplify it to make your professor happy, and it would be 3x to the power of 2 plus 6x plus 1. The next problem would be y equals x to the power of 2 plus 1 over x plus 2. You would first begin to differentiate the numerator, which would really just be 2x because 1 is a constant. The denominator would be 1 because 2 is a constant and the derivative of x is 1. Then we plug it into the formula for the quotient rule, which is here, and you can simplify it, which would be x squared plus 4x minus 1 over x plus 2 to the power of 2. Here, the equation is x squared plus y squared equals 16. The first step, if you can remember, is to differentiate the two sides. The derivative of 2x squared is equal to 2x, but remember for 2y, but remember for y squared it's 2y dy over dx because of the chain rule. The derivative of 16 is just 0 because it's a constant. So I now have 2x plus 2y dy over dx is equal to 0. Next, move 2x over to get 2y, dy over dx is equal to -2. And to finish it, just divide by 2y, and you get dy over dx is equal to -x over y. But this slide is pretty self-explanatory. You can screenshot it and save it for your notes. And for the next video, we'll be doing the opposite of derivatives, which is integrals.